Hello everyone, welcome back. So this time we're going to be jumping into units measurement, specifically units. Okay, think units. This is actually incredibly important and not important at all. Now, I'll go ahead and tell you why that is. I'll go ahead and show the screen first and we'll go from there. Okay, so why is it important but not important at all? Well, the answer for that is simply because in most of the problems, if not all in this class, I don't try to trick you. If I need a unit of force called a Newton, I give you newtons. Or I give you the stuff that will turn into newtons. If I need pounds, I give you pounds. And you solve using that. So there's no conversions usually necessary. It's not saying that doesn't ever happen. It's just, it's very rare in this class. In real life, it's not that simple. In real life, you're going to have to convert units all the time. So make sure that you understand how to do it. Now, if you've taken my engineering course, you've gone through some painful questions, and hopefully you've mastered it from that. If you haven't, but learn how to convert units and learn what they are and why they're important. People have died because of them. Billions of dollars have been lost because of units. So make sure that you don't make a simple mistake like that. Okay, so with that, let's go through this. So there's 4 fundamental physical quantities or dimensions: length, mass, time, and force. Now, this is actually lying to you. Force isn't technically a fundamental physical quantity or dimension. It's actually a derived dimension. But for the case of this class, we're gonna say that's true. Now, Newton's second law relates all of these from force is equal to mass times acceleration. You're like, well, wouldn't acceleration be the dimension then? Where's length and time? Well, you have the force, you have the mass. Doesn't make sense. Acceleration is equal to length over time squared. That's its dimensions. So there's the length, there's your time. So we use this equation to develop different systems of units. And the units are just arbitrary names we give to the physical quantities. Dimensions are qualitative. How far away are you? Or really far away? I'm right next to you. That's qualitative description. How old are you? I'm old. I'm young. Quantitative measurements use units. How old are you? 29 years old. How tall are you? 85 feet. I'm a giant. As far as you know from this computer, it could be true. Probably not. So, unit, quantitative, dimension, qualitative. Don't forget that. Now there's a bunch of different unit systems. The 2 that we're going to use the most are simply the international system, the SI, also known as metric, and the US customary system. Boo. Okay, I shouldn't boo the customary system. It's better than some. It's better than the American Engineering Standard. This one at least makes sense. If anyone says they want to use the AES system, just as a note, don't work with them. That's just bad. Okay, a little like a PSA there, but other than that, let's go on working. So, what are these things? Well, they're just telling us that depending on who you ask, they might have a different unit system. These are the 2 you're going to run into all the time in this class. In this unit system, 1 kilogram is the unit of mass for SI, and the slug is the unit of mass for the USCS. But they're not the same thing. Just because I have 1 kilogram, it's not the same thing as 1 slug. Just as I have 9 newtons, it's not the same thing as 9 pounds. As you can see, 1 slug is much, much larger than 1 kilogram. And 9 pounds is much, much larger than 9 newtons. So be very careful about that. You don't want to make that mistake. It's just something I have to figure out now. Because most of the world uses the SI metric system. And so if you were born in the United States, you kind of need to catch up on that. Okay, moving myself out of the way, guys. I move around a lot today. So here they are. Here's all the units. As you can see, luckily, seconds at least lines up. Everything else doesn't. We have meters and feet. We have kilograms and slug. We have newtons and pounds. If you're like, why are newtons and slug in boxes with a little star? Well, as you can see right here, it's saying it's a derived unit. This is a kind of a weird thing. In the US customary system, the pound is considered to be the base unit, and the slug is considered to be the derived unit. So if you know what the equation for weight is, it's weight is equal to mass times gravity. Oh, I'm way too close to the top of my screen. Weight is equal to mass times gravity. And as such, in most systems, at least in the SI, well, you see that weight's the thing you're solving for, so it's derived. I have an equation for it. In the USCS system, we say, well, most people don't know their mass, they know their weight. That's just easy to measure. And so what they do is they say, okay, well, we're going to be a little bit weird. We're going to say mass is equal to weight over gravity. So mass is therefore the derived unit. For this class, it's not super important. It's just how it is. And it's one of the few places that the USCS system actually shines, because if you ask somebody how much they weigh, most of the world's going to give you an answer in kilograms, and they're actually wrong. Kilograms is mass, it's not weight. The United States will actually get it right. We'll tell you our weight in pounds, or we might just slap you because how dare you ask me my weight? That's extremely rude. Actually, COVID-19 times, probably wouldn't slap you, just be like, shake a finger. Okay. So conversion factors, things you probably want to know. Pound to Newton, extremely helpful. Foot to meter, pretty much need to know that. Slug to kilogram, not really all that important. Do I expect you to memorize these? No, you have a textbook. Use your textbook. Write it down in your notes. Find it. It's online. You can literally just type in any number you want and convert it to something else. Should you do that right now? No. Please, 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 at least for this first homework, try to do it yourself. Try to convert yourself using the conversions you find in your textbook. Still use your textbook. Still use your notes. Don't use the internet to help you until after you know how to do it yourself. It's like if you never learn how to add unless you're using a calculator. You're going to run into issues where you don't have a calculator. Don't develop a handicap by constantly giving yourself some sort of crutch. Crutch is good if you need it, but if you don't need it, don't use it. So, can you convert a value of 47 pounds into SI units? Yes, we can. Let's do that right now. So 47 pounds. And then we have 1 pound force is equal to 4.448 newtons. And if I multiply all that out, 47 times 4.448 equals 209 newtons, roughly. Oh, it was there! So 209 newtons. If you want to see how I did that, feel free to go ahead and rewind and figure it out. Okay. So, last little bit here. And this is a little bit longer video than I normally do, but a lot to cover here. Here are some standards for the International System of Units, for the SI system. Most symbols are in lowercase, however there are some key exceptions. You should not use a compound prefix, which is saying there is no kilogigameter. That would be a terameter. Or there is no kilomegabyte. It is a gigabyte. You don't put both together. Separate units with a little dot. A lot of the stuff I don't really care about. The big thing for you is that you'll need to realize that in the SI system, we use prefixes to make things simpler. So what those prefixes look like? They look like this. You've probably seen this all the time with file sizes. Gigabyte, megabyte, kilobyte, all of them right here. Kilobytes, how many bytes? It's 1,000 bytes. Megabytes, how many bytes? It's 1,000,000 bytes. Gigabytes, how many bytes? It's 1,000,000,000 bytes. Do you need to memorize these? It would help, but it's once again not necessary. You can, if you need to, reference your textbook. Always remember that. You have a reference, use it. You have notes, use them. In real life, you use your references. But you still need to memorize some things, not because you're not going to be able to find it later, because it'll just save you a whole bunch of time. If every single time you have to use megabyte in this class, you have to go and figure out what it means, you're going to waste hours, because it's going to come up all the time. If every single time you see milli, you have to look up what it means, you're going to waste hours, because it's going to show up all the time. So some of these, it's just good to memorize. Okay, I'm going to end it here. I've gone way too long this time. But look at this. Make sure you reference it. And at least when it comes to prefixes, save yourself some time and memorize those. At least these ones right here that you can see. Well, hope you enjoyed this. I'll see all of you next time. Bye-bye.